Okay, hello guys. In this video we will discussing about the spanning tree protocol. For disclaimer, all images that I use in this video is from How to Master CCNP Switch book from Rene Molenaar and some huawei documentation. This video is part of my training to attend an interview test. So why we need the spanning tree protocol? What causes a loop in a switch network? The first we must know about the spanning tree background. Spanning tree is used to prevent loops in the LAN. The switching devices running STP to discover loops on the network by exchanging information with one another and block certain interfaces to cut off the loops. Along with the growth of the LAN scale, STP has become an important protocol for the LAN. So as you can see in this picture, if we are not have a spanning tree, the computer A, when sending file to the computer B, they will be looping in this interface between switch A and switch B. Yeah, for example like this. So how to fix this issue? We must to implement the spanning tree protocol in the switch A and switch B. Switch A and switch B, so the looping doesn't occur anymore in between these interfaces, because one of these interface will be blocking instead. This is will be blocking. So why we need the spanning tree? So in the next slide there is another topology. There are switch A, switch B and switch C. Let's guess who will become the root bridge. Okay, the switch A will become the root bridge because it has the lower MAC address. Okay, the switch A has the lower MAC address compared to another switch like switch B and switch C, because all of the switch priority is the same, 32, 76 and 8. So the tiebreak of the root bridge is MAC address. So you must configure. The first is we will see the priority. The lower priority will become highest priority, and then the second, the tiebreaker, the MAC address. The lower MAC address also will become the root bridge, the highest priority. The lowest priority, the more preferred. The lowest MAC address, the more preferred. Okay, so why the switch A will become this root bridge? In the spanning tree protocol, there are a BPDU. So what is BPDU? So the switches running spanning tree exchange information. They have a special message. There is a BPDU or bridge protocol data unit. All the information in BPDU is needed to create and maintain the spanning tree topology. As you can see in this picture, in this BPDU packet header, the only field that is important right now is bridge identifier. So pay attention to this bridge identifier. It contains bridge priority, MAC address. Also they have extended system ID, but that's not of concern to us in this moment. With the extended system ID, you must pay attention in the bridge priority and MAC address, because as we discussed before, the lower bridge priority, the more the switch will become the root bridge. Also the MAC address will become the tiebreak when all the switches bridge priority is same. So what is config BPDU and TCN BPDU? The configuration BPDU are the heartbeat packets. STP enable designated ports send BPDU at intervals specified by hello timer. TCN BPDUs are sent only after the device detects network topology changes. Configuration BPDU are most commonly used. During initialization, each bridge actively sends configuration BPDU. After the network topology becomes stable, only the root bridge actively sends configuration BPDU. So we can summary here. In config BPDU, only the root bridge that send actively configuration BPDU after the network topology becomes stable. Only root bridge that will be send config BPDU. But during the initialization, during init state, all switches send the config BPDU. But after the root bridge selected, only root bridge that send the config BPDU. The next is TCN BPDU. What is TCN BPDU? The content of TCN BPDUs are quite simple, including only 3 fields: protocol ID, version, and type. TCN BPDU are transmitted sorry. So the component of TCN BPDU is only 3 fields: protocol ID, version, and type. TCN BPDUs are transmitted by each device to its upstream device to notify the upstream device of changes in the downstream topology until they reach root bridge. A TCN BPDU is generated in one of the following scenarios: where the port is in the forwarding state and at least one designated port is set on the device, and then where a designated port receives TCN BPDUs and send a copy to root bridge. We will discussing about TCN BPDU on the STP Topology Change. Okay, the next is if you using the Wireshark and mirroring the one of the interface in STP topology, you can see the spanning tree protocol in the Wireshark. There are protocol identifier, protocol version, BPDU type, BPDU flag, root identifier, and then bridge identifier. The root identifier is the will become the root bridge, and this is the MAC address of the root bridge, and the bridge identifier is the current of the bridge priority and MAC address. Max edge, hello time, forward delay. Max edge default time is 20 seconds, and then hello time 2 seconds, forward delay 15 seconds. So the next slide we cover the 5 port states in the STP: disable, blocking, listening, learning, and forwarding. In the disable port, a port in disable state doesn't process BPDU or forward user traffic in the disable port because the port is down, so automatically the port doesn't process BPDU or forward user traffic. Down, doesn't process BPDU, doesn't forward user traffic. In the blocking state, a port in the blocking state receive and forward only BPDU, not user traffic. So in this port or port stage, they forward BPDU, they not user traffic forward. User traffic. They not forwarding the user traffic in the blocking state. In the listening state, all ports are in the listening state when STP calculation is being implemented to determine port loss. In the listening state, that's happen STP calculation. And listening state, we can also mention this state are transitional state. The next is learning. Learning also we can say that this is transitional state. So in the STP there are two transitional states. There are listening and learning. In learning, when a device has a port in the learning state, the device creates a MAC address table based on the received user traffic but doesn't forward user traffic. So in learning, there are MAC address table creation. MAC table. There is a MAC address table created. And the next, this is the final state, is forwarding. In the forwarding state, the switches forward user traffic and process PBDU. Forward user traffic and the PBDU. Okay, that's all about the 5 port states in the STP. So the parameters that affect STP port states, there are hello times, max age, and forward delay. In the hello time, the default interval is 2 seconds. Specifies the interval at which an STP capable device sends configuration BPDU and hello packet to detect link faults. When the network topology becomes stable, the change made on the interval takes effect only after a new root bridge takes over. The new root bridge adds certain fields in the BPDU to inform non-root bridge of the change the interval. After a topology changes, TCN BPDUs will be sent. This interval is irrelevant to transmission of TCN BPDU. The default is 2 seconds in the hello time. The next is the max age. The max age is specify the aging time of BPDU. The max age is specify time of the aging time of BPDU. The default interval in the max age is 20 seconds. The next is forward delay. In the max age, configuration BPDU are transmitted over the entire network, ensuring a unique max age value. After a non-root bridge running STP receives a configuration BPDU, the non-root bridge compares the message age value with the max value in the received configuration BPDU. If the message value is smaller than equal in the max age, if the message value are smaller than equal to the max age value, the non-root bridge forward configuration. The non-root bridge forward the configuration BPDU. But if the message age value is greater equal than max age value, the configuration BPDU age and the non-root bridge directly discarded. The non-root bridge discard it, and the config BPDU edge. Config BPDU will be edge. That is from max edge. The next is forward delay. I think change the color will be easier for us to understand this maturity. The forward delay default time is 15 seconds. The forward delay timer specifies the duration of a port span in both listening and learning state. Listening and learning state. The default value is 15 seconds. As I mentioned before, this means that port stays in the listening state for 15 seconds, then stays in the learning state for another 15 seconds. So listening 15 seconds, learning state 15 seconds. The port in the listening or learning state is blocked, which is key to prevent transient loop. So you must know in this state, listening and learning, the port is still blocking. This is the last of our topology. Our topic about STP. This is the STP topology changes. As you can see here, we have topology changes. A topology change is generated on point T. Here, topology change. The first step, the chain is going up to the root. This is going to the root bridge. The second step, the root advertise the topology chain for max edge plus forward delay. So after the network topology changes, a downstream device continuously sends TCN BPDUs to an upstream device. The downstream, for example here, let's say this is switch 4. This device continuously sends TCN BPDU to the root bridge, and then after the upstream device receives TCN BPDU, so after the root bridge they receives the TCN BPDU from switch 4. It means the downstream, only the designated port process them. The other ports may receive TCN BPDU but not process them. Next, the upstream devices sets the TCA bit of the flag field in the configuration BPDU to 1 and returns the configuration BPDU to instruct the downstream device to stop sending TCN BPDU. The upstream device sends a copy of the TCN BPDU to the root bridge. Step 1, 2, 3, and 4 are repeated until the root bridge receives the TCN BPDUs. The root bridge sets the TC bit of the flag field in the configuration BPDU to 1 to instruct the downstream device to delete MAC address entries. So for the summary, the TCN BPDU are used. We will back here. TCN BPDU are used to inform the upstream device and root bridge of topology change. This is useful for inform device and root bridge about topology change. Topo change. And then the configuration BPDU with the TCA bit being set to 1 are used by the upstream device to inform the downstream device that the topology changes are known and instruct the downstream device to stop sending TCN BPDU. Configuration BPDU with the TC bit being set 1 are used by the upstream device to inform the downstream device of the topology changes and instruct the downstream device to delete the MAC address entries. In this manner, fast network convergence is achieved. So for the summary, the configuration BPDU, the first is TCA bit is set to 1. To instruct the downstream device to stop sending TCN BPDU. Stop sending BPDU downstream device. And the second is TC bit 1. To instruct the downstream device to delete the MAC address entries. So in this manner that like I said before, the fast network convergence is achieved. So I think that's all. It's about the basic concept of the STP or spanning tree protocol. Thank you for watching, and the next video I will upload it about all about the networking material like STP, like RSTP, maybe MSTP, IGP, OSPF, SIS, etc. Thank you for watching.